Hello, good morning all of you. Dear students, after long break, now I am taking the class 10, chapter 1, part 1. This chapter 1, real number, I will be taking, and Anand sir has taken the last two exercise. That revision of that chapter I am doing. So, real number, this chapter is very important, and this chapter near about this is of 6 marks. So all of you pay attention on this. First of all, real number, this is first chapter, second chapter, third chapter, fourth chapter, and fifth chapter. This is called algebra. So in the maths, all the chapters are divided into units. So first unit is the real number, that is in 9th class, you have studied about number system. In number system, you have studied about all the types of numbers. That is, in 9th, I have explained what is natural numbers, what is whole numbers, what is enough. Here, this chapter 1, is real number. Now, when we talk about real number, so it is a real number is like a school bag. If I say 10th class student, you go to stationers and ask for the book, 10th class maths, 10th class book set I need, or 10th class copy set I need. So what if you ask for the book set, the shopkeeper give you all the books, English, Hindi, maths, science and all. If you ask for copy set, then he will give you the copies. How many copies, total copies will be required in 10th class. So this chapter is very important. Now I will explain real number. So real number, I am sharing this screen. On the screen, you can have the introduction of this chapter. The last, in the 9th class, you have studied about natural numbers. So natural numbers, if you go for that, it is represented by capital N. Natural numbers represented by capital N. And what are natural numbers? That is, counting numbers are called natural numbers. N equal to 1, 2, 3 and so on. So curly bracket you have to apply. Curly bracket, why we write? Because it is a set. It is a set of natural numbers. So if I talk about set of natural numbers, then n equal to 1, 2, 3 and so on. The smallest natural number is 1. If somebody asks you what is the which is the smallest natural number, then you will say smallest natural number is 1. Now if I ask you largest natural number, because there is no end of the natural number. Because it is after 1, 2, 3, I have put it a dot. Dot means so on. So it means that there is no end of the natural number. After 3, that is 4, then 5, 6, 7, 8 and all. And so you are getting the numbers. So this type of set where the dot is there. If I say n equal to 1, 2, 3 and dot, 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 so on, it means that it is infinite set. Infinite set, that is, the elements are not countable. So this is very important. After the natural numbers, here it is whole number. Second thing is whole number, and whole number is represented by W. So what is whole numbers? 0 along with all natural numbers are together called whole numbers. That is, W equal to 0, 1, 2, 3 and so on. So here you have to write W equal to 0, 1, 2, 3 dot dot, as we have written in n, natural number, n equal to. So same way you have to write in this. I have not put it W equal to. So you will write W equal to 0, 1, 2, 3 and so on. So again the question comes, smallest whole number. So what is the smallest whole number? Then you will say smallest whole number is 0. After this, now we must know even numbers. When we talk about natural numbers, that is 1, 2, 3, 4, 5, 6, 7, this all the natural numbers are divided into two parts, that is even numbers and odd numbers. There are different types of numbers. So before that, you must know even numbers. So natural numbers of the form 2n are called even numbers. This is the definition, exact definition, that is natural numbers of the form 2n. Or you can say that even numbers are the numbers which are divisible by 2. Numbers which are divisible by 2 are called even numbers. So if I ask you what is smallest even number, then you will say smallest even number is 2. Again, there is no end of the even number. So this is also infinite set. After that, we have odd numbers. Odd numbers, natural numbers of the form 2n minus 1 are called odd numbers. That is, if you subtract 1 from the even number, you will get odd numbers. So 1, 3, 5, 7, 11, 1, 3, 5, 7, 9, this type of numbers are called odd numbers. So again, the question is that smallest odd number is what? Smallest odd number is 1. So if we combine, that is even numbers and odd numbers, you will get natural numbers. Because sometimes what happens, that is 1 to 100 numbers are given, and you can say how many even numbers are there? 50 even numbers and 50 odd numbers. That is if 10 natural numbers are there, then you will say 5 even numbers and 5 odd numbers. So this is what we have. Now after that, we have prime numbers. Very important thing is the prime numbers. The natural numbers greater than 1, which are divisible by 1, and the number itself are called prime numbers. Up greater than 1 I have talked to, then what comes in the mind? Sir, you will have to take number greater than 1, not 1. So prime numbers have two factors, that is the number itself. Example, 1 and the number itself. Example, you can take 2, 3, 5, 7, 11, etc. and all. So if I say factor of 2, that is you will say 1 and 2. If I say factor of 3, 1 and 3. Factor of 5, 1 and 5. Factor of 7, 1 and 7. Factor of 11, 1 and 11. So this type of numbers are called prime numbers. 1 is not a prime number as it has only one factor. So you can say that 1 is neither a prime number nor a composite number. When we talk about the composite number, here comes what is composite number. So composite numbers are what? The natural numbers which are divisible by 1 and itself, and any other numbers or numbers are called composite number. You can say simply the definition, you can say what are composite numbers? Numbers which are not prime. Numbers which are not prime are called composite numbers. Simple definition you can keep in your mind. What is composite number? Composite numbers are the numbers which are not prime, because prime numbers plus composite number, that is including 1. If I talk about 1 plus prime number plus composite number, you will get natural numbers. So here the natural number which are divisible by 1 and itself and other. So any other number or number are called composite numbers. Example, you can have 4, 6, 8, 9, 10 and etc. 1 is neither a prime number nor a composite number. After this prime numbers, that is, we have one more thing you should have in the mind that I will explain, that is co-prime number. So co-prime numbers are the numbers, that is, you can have say co-prime numbers are the number which are divisible by 1 and 1 itself only, which are divisible by 1 only. That is, above number may be 4 and other number may be 5, 4 upon 5. This is what? Co-prime numbers. So that about the co-prime numbers, you will be I will be giving the concept of co-prime numbers in the last exercise, second last exercise, to when we are talk about the root 2 is irrational or all. Now after this composite numbers, we have integers. Very important thing, integers. Integers are represented by I. That is all numbers from, that is, I have put it this dot dot -3, -2, -1, 0, 1, 2, 3 and so on are called integers. That is, this is dot dot means you can represent integers on the number line. That is, you are, if you know, in 9th class I have explained about the integers, and when we talk about integers, that is number line, you take 0 in the middle, and on the left hand side you mark negative numbers, and on the right hand side you mark positive numbers. So horizontal number line I have explained. After that, that horizontal number line we have given another name, that is known as the x-axis, and vertical number line is known as the y-axis, and you can represent on the graph paper, and it becomes a Cartesian plane, and that is the introduction of coordinate geometry introduced in that. So we are not talking about that. Integers, when we talk about integers, so you can say that all positive and negative natural numbers including 0 is called integers. Now when we talk about rational numbers, so rational numbers is represented by Q. That is, now rational number, when we talk about rational numbers, you know that any number which can be written in the form of P upon Q. In the form P upon Q. Here the real numbers of the form PQ. This is wrong. So you have to make the correction here. That is form P upon Q. This is P upon Q. Here you can put the slash. That is real numbers of the form P upon Q. Q is not equal to 0, and PQ are integers, are called rational numbers. So after this you have, that is, all integers can be expressed as rational. Yes, that is 5 upon 1. That is 5 equal to 51. It is not 51. It is 5 upon oblique. That is 5 oblique 1. All integers can be expressed as rational. That is, you know that negative integers are there, so negative rational numbers you will get. If positive integers are there, you will get positive rational numbers. So this is what. Now rational numbers can be represented into decimal form. Decimal expansion of the rational numbers is what? Terminating and non-terminating recurring. This you have studied in the 9th class, decimal expansion. So decimal expansion of rational number is that is terminating and non-terminating. When we talk about rational number, suppose I say 6 upon 5. So 6 upon 5 is what? 6 is the numerator and 5 is the denominator. When I divide 6 upon 5, so what you will get? That is point, if I say 1.2. So when the remainder is 0, then you say it is terminating. If remainder is not 0, then you say non-terminating. But if I say 10 upon 3, then you will say, sir, 10 upon 3 is a rational number. But if I convert this in the decimal form, you will say that 10 upon 3 is what? 3.333 and so on. That is 3.3 bar. You put the bar on that. And this bar is what? Recurring. This 3 is repeating again and again. So you put the bar. So decimal expansion of rational number is 3. The decimal expansion of 10 upon 3 is what? 3.3 bar. And 3.3 bar is non-terminating recurring. So recurring means repeating. Non-terminating means remainder is not 0. But when we talk about irrational numbers, so again we have irrational numbers, real numbers which cannot be expressed in the form of P upon Q. Here PQ is written, so it is P upon Q. That is P oblique Q. So whose decimal expansion are non-terminating and non-recurring. That is, if somebody asks you the decimal expansion of irrational number is what? You will say non-terminating and non-recurring. It will not repeat again. So it is non-terminating. Remainder is not zero. So irrational numbers, simple definition you can say, somebody asks you what is irrational number, then you can say that irrational numbers are the numbers which are not rational. If I talk about rational and irrational, that is rational and irrational numbers are two types of number. So after this we have prime roots of prime numbers, that is 2 under root 3, 2 under root 3, under root 5 are irrational numbers. So roots of prime numbers like root 2, NOS is what? Numbers. So you can have, this is a short form of that. So root 2, root 3, root 5. If I ask you what is the value of root 2, you can have studied in the 8th class to find out the square root of 2. That is, you have calculated up to 3 decimal places, 4 places. So 1.414 and so on, so on. So we put the dot. It means that it is non-terminating, non-recurring. Root 3 is what? 1.732 dot 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 dot. Root 5, 2.236 dot dot dot. It means that the decimal expansion of irrational number is non-terminating, non-recurring. Remember this, all natural numbers are whole numbers. All natural numbers are whole numbers. Whole numbers are integers. All integers are rational numbers. All rational numbers are real numbers. So here one word comes real number. Real numbers, when we talk about real numbers, rational and irrational numbers, all rational and irrational numbers are called real numbers. That is one thing is missing. All rational and irrational numbers are called real numbers. So simple definition of real number is what? That is all rational and irrational. That is all type of numbers comes in the real numbers. You can have a simple definition of real number, that is rational and irrational. This is two type of category. If we talk about the human body, we have two type of body. One is male and another is female. So rational is male, irrational is female. Now, when I talk about male category, that is of any age. If male gender is there of any age, it is comes in the male category. If I talk about female category, then irrational number. That is, if a male can wear the clothes of female or female can wear the clothes of male, but it is not the gender changes. Only the role of the person changes, but rational and irrational numbers are called real numbers. That is one thing you have to remember. What is real number? You will say rational and irrational numbers are called real numbers. All rational and irrational numbers are called real numbers. After that, that is Euclid division lemma. Before this, now very important is what? Euclid division lemma. Today I will be explaining. You have studied, you have not studied Euclid's chapter in 9th class because it was deleted, and Euclid was mathematician who has given the different theories, but here he has given the theory of division. Long division method, all of you must be, you have studied till now long division method. So you in long division method, what is there? That is dividend, we know, you know, dividend, divisor. After divisor, we have quotient and the remainder you get. So you have studied about the division, long division method. And in long division method, if you divide, if I ask you divide 8 by 3. So what do you say? 8 is the dividend, 3 is the divider. How many times 3 goes in 8? That is 2 times 3 to just 6, and remainder you are getting 2. This is correct. Now, why this is correct? If so you have written 3 ones are 3 and 8 minus 3 is 5. If you are writing 5 as a remainder, then teacher marks wrong. Why it is wrong? Because it is not satisfying the Euclid division condition that is written on the screen. That is that is two positive integers. If I take A and B, A means 8, B is 3, and if you this is the condition: A equal to BQ plus R greater than equal to 0 and less than. Here it is the mistake. R is less than B. Here it is R is less than B. It is not. Yes, yeah, very less than B. So this condition is very important. R is less than B. Remainder should be less than divisor. Then only you say, because if you are dividing 8 by 3 and you are writing 3 ones are 3 and the remainder you are getting 5, then you will say further it can be divided. So very important. This is what Euclid division lemma. That is, if two integers are given, A and B, A is greater than B. If because long number that is greatest, A is greater than B, then A divided by B, you can say A is the dividend, B is the divisor. How many times it goes is it is a quotient, and the remainder is there. So this should be, so when you are dividing, that it is divided by the numbers. So lemma is a proven statement. If I ask you what is, you will get two terms here: Euclid division lemma and Euclid division algorithm. Two things you will get: Euclid division lemma and Euclid division algorithm. So algorithm means step by step. That is first step, second step. You have studied in the computer. When you are making a program, then algorithm you make, and according to that algorithm, you can have solve the problem in computer. If comma is mistake is there, you find that you are unable to activate the program. So this is very important. So a lemma is a proven statement, and algorithm is a step-by-step method to solve the. Now, application of lemma, that is Euclid. This Euclid division lemma, that is SCF. If you know what is SCF, SCF is highest common factor. This method is used to find out the SCF. You have studied the long division method in 4th class. That is how to find the SCF by long division method. Again, we are studying in 10th class how to find out the SCF by long division method. So this method again I will explain. So in next class I will explain this. Next class. Thank you, beta. In next class I will explain Euclid division lemma. That is